Hey folks, welcome to this episode of the Application Security Podcast. This is Chris Romeo, CEO of Security Journey and co-host of said podcast. I'm also joined by Robert Hurlbut today. Hey Robert, how's it going?
Hey Chris, Robert Hurlbut. Good to be here, threat modeling architect, and really interested in our topic today.
Yeah, and we've spent a lot of time, I would say, in the last year talking about things that intersect in the DevSecOps world. And so we're going to continue down that channel or that path today in talking about security automation in continuous integration, continuous delivery, maybe even a little bit of continuous something else. But we're joined today, and I'm going to say your name, and then you're going to correct me because I practiced for seems like minutes, but Jeroen Willemsen. How did I do?
Very well pronounced, sir. Jeroen Willemsen, but yeah, it's a typical Dutch name. So yeah, if everybody knew we were working on non-Dutch podcasts or anything else, would probably call me Jay.
Well, we'll stay with your original name, no problem there. So we always like to start by asking our guests, what is your security origin story? If there was a comic book that described your career in security, what am I going to find in episode number 1?
There you will find a poor kid not having any money for playing at a computer, and then with a mischievous friend working out a VBA virus to take over some controls at the school network to be able to play Quake with each other.
There is a story. I need more details in that story. I'm sorry, I can't. That is, it's a fascinating idea that you wrote a Visual Basic, I'm guessing macro, that generated some amount of control. You must tell me more. I have to know more about this story.
Yeah, so what basically happened, most of it was written by that lovely friend of mine. Let's not call any names right now. But I basically joined him and figured out a few of those register keys that we had to manipulate in order to take off some control and then be able to open a few more network spaces towards each other so we could see each other in the computer from a direct connection, and then we could play games together, basically. We also had some funny buttons written as part of a VBA interface where you could launch Quake and stuff like that. Really silly, but it worked. And on the very next page, you'll see the same poor kid hustling around with smartphones, wanting to play games again, because I'm a gamer. And because the games just didn't run on my budget smartphone, I had to go all the way trying to understand how these custom ROMs worked in the early Android days and how to further kill off stuff that I didn't need and how that worked in general, what did it mean security-wise. And then all of a sudden at one of those forums you saw a lot of weird things going on in terms of what happened with keywords and whatever you typed in there. And that's what got me interested even more. And that's how we got into mobile security in the first place.
So is that what you say, is that kind of your primary specialty right now, is security in the mobile space or general AppSec, or where do you land today?
I think it's general AppSec, but I always have a big interest for mobile because, we always wear our smartphone with us and do funny stuff on that thing. So, always caught my interest, basically.
Just diving in here, one of the things I think we're talking about today is security automation. And I know that, in my own development career, one of the things that we always focused on was how can we automate? How can we automate? But what do you mean by security automation? What does that mean?
So security automation is a very broad category of a lot of things that you can automate nowadays. It's I think most people already in the DevOps world are familiar with the old type of things like applying your SAST, your static code analysis on whatever you have landed there. And then, of course, you have your third-party dependency checks with something like dependency checker. Then, of course, you have your dynamic analysis. And on top of that, you can have your analysis of the containers you run, of the compliance posture of your cluster where you run your applications on, whether that's on the nodes that serve them or the cluster as a whole, if you talk about Kubernetes, for instance. Then you have your cloud compliance posture automation, however you want to call that, because there's different names to that. Depending on which vendor you ask, you'll get a different name. But the idea is, of course, to see hey, are we doing stuff secure enough, or are we compliant with some sort of security standard that postulates what you have to do out there? And then the very next step, of course, is automating offensive playbooks to see if you can actually simulate certain types of attacks towards that stack that you just try to get your fingers on in an automated fashion. And then, of course, there's the whole automation you can have in triaging findings that you have, security enumeration, vulnerability analysis, the whole vulnerability management in general, as in get insight on whatever you have out there and how you're going to triage that all over your systems and different tickets. So that's more of the, what you normally focus on with secure automation. We talk about that, and then there's this small part where you can do beautiful things like assisting developers whenever they create a ticket to work on something. You can also do a lot of automation over there, but I think that's more process automation, I guess. But yeah, that's all the stuff that we talk about when we talk security automation nowadays. And of course, incident response, automated SOAR, blah blah blah, all that stuff. So it's very broad nowadays.
Yeah, it's a pretty broad grouping, and I'm just realizing, because the three of us, we play in the AppSec space, we're very engaged in DevOps and DevSecOps and understanding all these pieces. But if I think about how somebody's going to receive that list that's new to, maybe they've studied DevOps, but they haven't really thought about how security goes in, that's a pretty complex equation that you just described, right? Between SAST, DAST, SCA. You didn't even mention IAST and RASP, you might have, but those are another potential play, and then you got into the compliance and the container checking and vulnerability management. How do we make this easier? Why is this so complex? Why is security automation such a complex problem?
That's because we made our software stack a complex problem. You get so many running components before you have any software running nowadays. And then that software itself comprises of many components as well. And to the best of my knowledge, there is no tool that covers everything and just tells you, oh, this is your complete security posture for all these components together. So in order to be able to analyze any of these running components, you need a tool or a process that fit for that given component, because the component changes, so does the risk with that component, and therefore how you have to detect that. So the security complexity just reflects what we did as software engineers to make stuff also complicated.
So we're passing the buck, right? As security people, we're saying we didn't make this problem. It was the software stack that we inherited that made. We just had to secure on top of it, which you brought us complexity. You should have brought us simplicity.
Yes, and possibly budget, because you could have had budget to focus on multiple components altogether. And we see some tools doing that and being successful at it. And then you see the price tag, and if you then go as a developer to your boss saying, I want this tool, your boss will say, wait, what? Why so much? That's an interesting conversation.
Yeah, and if you think about that space, there really isn't anybody that, to your point about, there's no super tool that solves this problem from end to end. There's some vendors that have a SAST play, an IAST play, a RASP play, maybe even an SCA play, but they're kind of those are almost like the table stakes of the secure software pipeline. Those are the ones that the categories everybody knows. There's been 1 million webinars about those, and there's 1 million products that cover those. And so there's a few vendors that have a consolidated approach to those, but they tend to not have, you have to almost go to a point vendor to get to, container security. Nobody's got a single package that solves all of this. And so I think that's some of the struggles that we have in implementing this, because to my kind of original point, you think about this as someone who's brand new, and they're probably stuck asking, why do the people in AppSec have 4-letter acronyms for every tool that they use?
Yes. Yes.
That's probably, they're probably stuck on that level of, and so I think one of our challenges that security automation needs to help is, it's not only automating and making things simpler and more repeatable, but there also has to be an angle of how are we making things less complex? Because I've been hanging around the world of security for, I just realized, almost 25 years at this point. And one of the principles I learned on day one that I've tried to live the whole way through is keep it simple. Simple equals secure, complex equals insecure or broken. And that has held true throughout my career as I've watched everything happen. I've watched the level of complexity grow to this monster that we have. And you can attribute a lot of security problems to complexity, because if there had been a simple answer, then someone would have been able to make the secure choice. It's the fact that they had 27 different things that were all feeding into it, and they missed one of them, and then we got a breach, we got an incident that comes out of it. So that's, I guess, my soapbox moment on complexity and security.
Totally agree there. Can't agree more to that one. Yeah, so to simplify it a bit is to always look at the context you're operating in. If you're a software engineer, like a DevOps engineer, focusing on writing certain code, let's say you're in the Node ecosystem and you're writing TypeScript stuff for a backend and doing stuff like that, then there is a given set of tools that can help you to secure your to validate the configuration of your Node deployment, of the container that's having that, of your dependencies in there, because that's already packaged with latest version of NPM, like NPM audit, so you have some basics. And there's a basic set of tools you can always use to start. If you're one of the guys at something we could call a platform team or a site reliability engineering team or the cloud team that basically needs to get these teams that have these Node applications up and running, then you have your own problem space that comes with their own security tooling. And that separation has always been there. You hardly see SRE teams saying, we'll write better JavaScript code than you do. And you should possibly also not say, we'll be able to better wield your security tools than you do. Just let somebody use the tools that work for their problem space and keep it small. That doesn't mean it's getting less complicated. It just means we can focus on the complexity that's offered to us at this point in time. Unfortunately, I don't have a better answer. I rather would like to say, okay, let's use language X that doesn't have this. There is no such language, to the best of my knowledge, that is used outside of scientific papers on modeling something scientific without doing anything, unfortunately.
Yeah. In the danger of creating a monster fight on social media, I'm going to share an opinion based on my own study and some people that work with me that have been influencing me in thinking about given languages. And so the language that some of our developers here at Security Journey have gotten really into is Go. And one of the things they're saying about Go is, and I'm not a Go, don't come after me and say this guy was like saying that Go is the only way you could do stuff or anything, but what they've shown me is there are some patterns in Go where it's very difficult to have an insecure option, because Go is locking you into, nope, you can't even do what you want to do insecurely. Like you think about like frameworks, modern web frameworks. There's a lot of good web frameworks that have good secure options by default, but they always give you a way. But we've got this extra routine here for the workaround, so that if you have legacy code and you don't want to deal with security properly, you can enable this. And I love it's React that has React has a funny name for it. It's like insecure or whatever, like something like that. And so to your point about like there is no language. When I think of Go and I think of the future, I think that's where our languages and our frameworks need to go to limit complexity, is to say, let's bake those secure defaults in and say, if you want to use our language, this is what you're getting. There is no way to pull the pin and make it insecure. You want an insecure option? Go use PHP. Why is it still the number one language on the internet? That's a conversation for a different day.
Yeah. What I really like about Go indeed is that they put it that way. The only problem is not everything that the world's using is available in Go. So you see people linking C compiled stuff and C++ compiled stuff into Go libraries, and then the whole thing goes back to 1995, which is great because it's a great year, but it might not be a good day for having no security vulnerabilities in your total code base.
It was a great 1995.
Totally agree. It helps a lot.
It was a great year. Robert and I were both young men at that point.
Yeah. Too far back to even remember. Well, I can remember, but I don't want to remember right now. So far.
All right.
So far away. Hey, in terms of somebody getting started, they've never done this. They're trying to look at what they can do and switch over to start using security automation. What are some quick wins, typical quick wins that somebody might see when they get started?
So it kind of depends on the role you're at. So if you're a typical software developer creating an application that consists of some code yourself and having those dependencies in, start having a look at your dependencies with open source tooling like the OWASP dependency checker and see if you can use that tool to see whatever is going on with your dependencies. Or look at which tool has already been out there for your given language, for instance, like npm audit for node tools. And there's a few other languages that have their own typical vulnerability third-party package analyzer as well. Start with those. Keep it simple. Look at if you have a given language like, for instance, Java, start first with actually not rather the security of things, but the quality of your code. So it becomes readable. And after you got the readability figured out, then start looking at extra plugins for those to check for security vulnerabilities. If you're a typical infrastructure guy running containers, then start with something like Claire or Trivy or whatever to do start container scanning, just to keep it simple, as lightweight as possible. No complicated client-server technology, so Trivy will be the way to go nowadays. If you're on trying to get something done within AWS or another cloud provider, have a look at Prowler or Scout Suite and just start looking at an overall analysis of your cloud security posture. So those are 3 typical things you could get started to get a little bit of an idea of how well you're running, how well stuff is looking. And then from there on, you can continue growing forever. Similar like your code base might be doing nowadays.
So you mentioned one. I had heard most of the ones that you mentioned. I'm aware of most of them, like Claire and Trivy from a container security perspective. And one point, just to kind of second something you said, one of the things that we've done in our approach to secure coding is we always make sure we're teaching, the value of linters, the value of prettiers. Like, it's not really a security, it's more of a quality issue, but the higher quality your code gets to, the more secure it's going to be. Like, that's just common sense. But you mentioned, I've never heard of Prowler. What is Prowler?
So Prowler is similar like Scout Suite, is a tool you can use to do analysis on, I think right now at least AWS in terms of your cloud security configuration. It has certain modules to test the security posture. It also has certain modules to aggressively try to exploit given vulnerabilities, for as far as I know. And it's relatively easy to script. And to parse the output in that sense, similar to Scout Suite, where Scout Suite is just a few single commands away to get yourself started. Probably you can do a modularized approach for as far as I remember.
So it's going to be checking like my AWS. It's going to connect and then grab a bunch of information about the services I'm using and the configuration, and then try to give me point out some things like, hey, you've got an S3 bucket that's public and wide open to the world. Don't ever do that, please.
Exactly. Yes, exactly.
Okay. I'm going to take a look at that. That's one I'd never heard before. So this is why we do this. I'm here to learn.
We learn a lot. We learn a lot.
So let's flip the table a little bit now. So we've talked about a lot of positive things. You gave us some case studies of early wins that we could do from a security automation perspective. But what are the potential downsides of automation?
So the first thing is that the automation gives you a lot of data, not necessarily information. The difference is, for instance, if you're new to AppSec in the first place and the tool starts telling you there's a CSRF vulnerability with the given library if you enable the following option, then the first thing we need to ask ourselves, what's a CSRF vulnerability? And B, where did I never enable that option? And C, if I did it enable it by itself? That's a whole lot of thing we need to research before we can continue. That's not just for one finding, but for many findings. And we know if we don't and it's enabled, then people might be able to exploit that CSRF vulnerability in our web application. We're in trouble. So we're kind of forced to start doing that. Before that, we could run away and move ahead. But the amount of information that comes from this or first data like this is huge. And then we'll see a lot of, for instance, false positives that tell you like, hey, there is this vulnerability reported on this binary you have in your Docker container, and the only reason you're having that because you're having some sort of fat container that used this binary to install something else, and then we removed it. But yeah, given that your tool was only looking at layers and not at the total composition of things, we got this reported. And before you figured out that when you try to find a tool inside your container, you're a day ahead, finding out it's not there. You start wondering why, and the whole thing that happens with typical container security. And then you realize, okay, we can suppress this false positive. So there's a lot of work that comes from triaging. And we also have to make a lot of more tougher decisions, like, hey, this is a typical vulnerability that I found, and with this sample exploit code that you can sometimes find on the web on certain vulnerabilities, I see I'm vulnerable right now, but the maintainer says, not my problem. I'm not going to patch this ever. What are you going to do? That's a whole different subject again. So we shift from not knowing at all to understanding we got trouble. It's actually quite similar for most DevOps when you start building your first code as a typical script kiddie without doing any actual testing. And the moment you start ramping up your end-to-end test, your integration test, your unit test, you find out, ooh, my code might not work as I intended. That's a lot of work. And now we do the same thing in the security space. We find out we might be in trouble, have to find out whether we are for real, and then fix it. So we just got a lot more work out of that. Work that's useful, bringing value, but a lot of work, depending on your stack.
Yeah, I see that, when you're talking about false positives, you're talking about care and feeding of the secure software pipeline. Those are things that are definitely downsides to implementing security automation. So who do you see as the people that have to deal with that care and feeding? Is that the SRE, the site reliability engineer? Is it the security engineer? Is it a cross-platform collaborative style team that's doing that care and feeding, or what's the source, or who's providing the resources there?
It heavily varies and depends on how you organized your DevSecOps organization in the first place, and depends on how much freedom a team has to do stuff. But the higher you start, the better it is. I mean, we can focus all over the place on typical vulnerabilities in our application code running inside a container that might allow for privilege escalation. But if we have this running on Kubernetes and we just basically made sure that nobody can run as root and that there's no readable file system, and we lock down all of the privileges that could possibly be there, yeah, good luck running as trying to escalate. Where are you going to escalate to? There's nothing to hold on to. Have fun. We'll just ditch the container every now and then and move ahead. At the same time, that doesn't mean that there's no problem. It just means we localize the problem to that given container. So yeah, we should start high, but it doesn't mean we shouldn't do the lower hanging fruit as well, because eventually we want to make sure we get proper control over the process which is currently vulnerable for being, for having its control taking over. So yeah, we start with SRE for again, focusing on the tools that they have to wield to secure their posture, as a security team that is, and then together with, for instance, platform teams or others, try to create similar tooling for the DevOps teams. And sometimes you do that with the teams because they have the freedom to run this themselves, and then you have to look for which team is capable to do this, because you do need to understand the stack you're running with, and that varies per developer whether they know. Sometimes I get people at my desk saying, yeah, it's my first year as Java developer. I didn't even know that this part existed. And then we just, direct them to Java experts, not to the security team, but to Java experts first. Because like you said yourself, clean code, good code, starting point. It's not the security team. But after that, you have to find the teams that you can collaborate with to develop those parts of the pipeline in a way that it's sensible for the developers. Because the moment you do this belly staring as a security team, it takes a little while before some of those parts of the pipeline might be discontinued, or they find bypasses or other funny things. So yeah, try again to collaborate in the space where the tool is aimed at. So you know that the moment you have to do the carrot feeding, you can do it in a sensible way that actually speaks the language of the user. Because otherwise it's a lot of discussions and thou shall, because I'm security. That's not how we build relationships right now, I hope.
I have a whole talk on that exact topic on developers dislike security. Is what it's called. And it's you summed it up there in that one statement. It's us as security sitting there going, well, we're security and we know what we're talking about. You know what? That's an antiquated look at the world. And for most of my career and Robert's career as well, that's what we've seen. That's even what we did. But there's a number of people that are opening their eyes and realizing, like, It's about collaboration. It's about empathy. It's about working with these developers and seeing how can we work together versus saying, oh, I'm from security. Of course I have the answer. I don't have all the answers. You heard it here first, right? I'm from security and I don't have all the answers.
Right.
In fact, in these conversations, if you put it like this and you keep it close to whoever you're working with, a security team, you'll learn so many cool things. I've seen the evolution of Java through the eyes of Java developers. I thought I knew Java a bit. Turns out I do a lot more now, still have a lot more to learn. But overall, it's been a beautiful journey to work with them. Similar to the guys who, moved from Java to the Go ecospace and figured let's do this more natively because, hey, Scratch containers, that's easy to maintain. Let's do this stuff. And it was been a beautiful journey. I wouldn't have learned this myself. And I really hope that most people that have a directive position like security or architecture or whatever mid-level management in terms of operation lead out there will eventually do the same thing, because it's the guys typing the code that actually know. It's that simple. Mm-hmm. Or eventually know. Everybody has to start somewhere and grow, blah, blah, blah. But eventually you get there basically, and possibly faster than we security people do.
Mm-hmm. So I'm going to do something different here for the conclusion of our episode. Robert, I'm going to go first, but I'm going to come to you next for a key takeaway. We're each going to share a key takeaway, and this is completely off the script, but hey, sometimes we just got to mix it up and try different stuff. And I would say that the thing that I really took away from this conversation was the complexity that security automation does bring. I don't know why I just hadn't thought of it from that perspective until we went down this road, and I started thinking about this through the eyes of somebody who is not a security person, is perhaps maybe like, let's say, a mid-level developer, someone who's been coding for 5 years. They're still early in their career. They're still trying to figure out how everything fits together. It's like, that seems like it would be so overwhelming. All of that security stuff we just piled in the back of the dump truck and dumped over on top of them. I'm just envisioning this developer stuck underneath this pile, of all these tools and technologies and things. And so that's really opened my eyes to say, how do we break it down? How do we make it more simple? So that's my takeaway. Robert, what's your takeaway before we go back to Jeroen?
Yeah, I would say similar. I mean, one of the things that mentioned was about data versus real information. I could remember that would be, as a developer or working with developer teams, is, okay, here's your list of all the things we found. And out of that list, maybe, 20 out of 1,000 or something like that might be real vulnerabilities they need to look at and think about. But you give them the 1,000 list, or they receive the 1,000 list, and they look at it and go, what do I do with this? And so, yeah, it really calls out that we've got a lot of great tools, and we should look at it, automation, because it really does bring some value. But we also need to think about how do you parse that data into real information that can be usable and actionable by those developer teams to do some good work. And they want to. I mean, most developers I know, being one for many years, you want to do good work. But if you're not given something that you can actually act on appropriately or quickly or understandably, then yeah, it's just noise.
Yeah. All right, you heard our key takeaways, so now it's time for the call to action here. So, Jeroen, what do you want our audience to take away from? What do you want them to go do now as a result of our conversation?
2 things. First thing is, for all the DevOps people out there that don't have that many tools in there yet, start looking at your operating space. Start looking, just putting the terms into Google, as in, if you're an SRE engineer, you heard Scout Suite, you heard Prowler. Start Googling it, see if you find alternatives. If you're just one of the guys that creates Docker containers, start looking for this Claire, this Trivy, and other stuff. Just start looking for the different tools out there. If you're a security engineer and you're listening, other than reducing the signal to noise ratio, make sure that you also secure the pipeline that you use to actually use these tools. Because skipping might be one problem. Don't forget about the massive problems that you have when actually attackers take control over that pipeline as well. So don't just let other people use the tooling that you want them to use. Use them yourself first. Make sure you're in a good shape. Otherwise, we're in a far deeper pile of poo than we would have been if your developer forgot something.
That's very helpful. Those are some really some call to action items that you can really sink your teeth into. Go look at the tools, and for security people, understand the pipeline, understand what you're putting people through, because that's you have to understand it before you can ask other people to do it. So, Jeroen, thank you so much for sharing your knowledge with us today, with our audience, about automation. And I know you've challenged my thinking on a number of different things. And I'm going to go check out Prowler, because I've never heard about this tool. So I love the fact that I learned something new today about a tool that I didn't know even existed. So thank you for being with us, and we'll invite you back sometime in the future in another episode to talk about something else in regards to DevSecOps, or maybe there'll be something new by that point. Maybe there'll be some new methodology. Who knows? But thank you once again for your time, and have a great rest of your day.
Thank you so much for having me here. It's been really an honor, and it's been a pleasure. Thank you so much.